Welcome to our roundtable discussion about improving mathematical teaching practices or pedagogy, while also demonstrating how to implement the mathematic practice standards. My name is Brian Simeone, and I'm joined today with Maria Ceres and Audra Christ. We are the instructors for online courses for the NJCTL mathematics program. And now I'm going to turn it over to Audra.
Thank you, Brian. When teaching slope, many of us are used to seeing students express the slope as run over rise instead of rise over run. We are going to talk about strategies we can use to help students who have difficulty expressing and conceptualizing slope.
This mistake is understandable. Ordered pairs are expressed as x comma y, and alphabetically x precedes y. So expressing slope as rise over run, y over x, is counterintuitive at the beginning level.
If a teacher introduces slopes using graphs, it's important to emphasize rise over run and assist students in making the connection between rise, the vertical component, with y, and the run, the horizontal component, with x.
Can either of you think of a way to help students remember that slope is rise over run, y over x, or perhaps provide practical illustrations?
You may or may not know this, but I used to use this in my classroom all the time. When walking up a flight of stairs, naturally your leg rises up first and then extends outward to take the step up to the next rise. So your leg partially extends outward second and goes up first. This is very intuitive movement for all of us, and it could really help students understand that concept better because the leg moves up first and then moves over.
That's very interesting. I'll have to try it. If you relate slope to real-world applications and how they are typically graphed, it is easier to understand. A classic example is the speed of a car, traveling in miles per hour. And when graphing a moving object in the coordinate plane, the time it takes to travel is typically assigned to x, and the distance being traveled is assigned to y. The distance traveled is the rise, and the time is the run. Slides 98 to 101 of our Algebra 1 Graphing Linear Equations presentation has examples and formative assessment questions containing this type of application problem.
Thank you. It was good insight from both of you. And thank you, Audra, for bringing up the components that the NJCTL offers, particularly slides 98 to 101. I would like to move the conversation to a slightly different direction and discuss the numerical representation of slope.
That's a really good point, Brian, that you bring up. The numerical representation of slope also is represented in fractions with the numbers. For example, let's say we have the slope of -1/2. That negative value could be placed to the numerator or the denominator. But let's look what happens regardless of which one we do graphically. So let's take a +1 over a -2. Still the slope of -1/2, but the way we would move on our graph would be up 1 and to the left 2 units to represent that -2. Then I can repeat that, go up 1 more time and to the left 2 more units. And you'll see a negative slope is created as we intended it, as we thought it would for a -1/2. But if I go and try to do it the same thing with the slope being -1 over +2, and I start at this point, now I'm going to move down 1 and to the right 2 units, leading me right back to where I was with the other fraction. So this fraction is exactly the same value numerically because it also graphically creates the same slope.
I think also, too, I've had a few students, and I think we've all experienced that aha moment when we see the students connect the arithmetic to what they're visually seeing on the slope. You know, arithmetic, the quotient of a positive and a negative equals a negative number, regardless of which number is negative. And when they see that on the slope, it creates that aha moment when they make that connection.
Yes, I agree. And also, if you would have even started at the original y-intercept of the origin and then went down 1 into the right 2, you would still get to a point that was on that same line. and you can draw the line going in either direction and you would still get the same value.
Now Maria is about to show us with the quotient of two numbers having the same sign.
Audra, would you like to talk about this one?
Sure. So this time we have a slope of 2/3 and we're comparing it to a slope of -2 over -3. Let's start with the positive. So if we begin at the origin as our y-intercept, you could begin at any point in reality, but let's just do the origin for simplicity. The first fraction tells us to go up 2 and to the right 3. And then if we repeat that process and go up 2 more and to the right 3, we'll end up at the second point. And then if we connect all of our points, we have our line that has a slope of 2/3. Now, if we were to start at any of the points that are on that line and examine the slope of -2 divided by -3, we can start at that one. And if we go down 2, that's -2. And then we would have to go to the left 3 because that 3 is negative and left is that negative direction. We would end up at the exact same points where we started. And as I was saying before, even if you started at the origin and you went down 2 and to the left 3, you would still end up on that same exact line.
Well, thank you. And these are all excellent contributions and great insights. That's all we have time for today. So I want to thank you for joining me and sharing me your expertise. And for our audience, join us again next week for our next roundtable discussion.